Welcome everybody. Today we're going to discuss simple machines, and we're going to focus on the three that are the lever, the wheel and axle, and the pulley. So let's just jump right in. The six simple machines, or there are six simple machines. The reason we kind of combine three here, the lever, the wheel and axle, and the pulley, is that the base simple machine for all three of these is the lever. So the lever is the acting force behind the wheel and axle and the pulley. And all simple machines are mechanisms that will manipulate the magnitude of force and distance, and they'll use something called mechanical advantage, and we'll get to that in a minute. The three we're not going to talk about, that'll be in another video, are the inclined plane, the wedge, and the screw. They are separate because the inclined plane is kind of the base simple machine for those. We'll discuss those later. So simple machines provide for us something called mechanical advantage. Mechanical advantage is, in general, it's the ability of a machine to make work easier for us, or to make work happen over a shorter distance. Mathematically, it can be calculated as both the ratio of the magnitude of the resistance and effort forces, which kind of sounds like something that may be confusing right now, but it's really quite simple. It also mathematically is the ratio of the distance traveled by the effort and the resistance force. And we'll talk about how those get used together for our problems later. When we calculate these ratios, we can figure out how to manipulate speed, distance, force, and function within our simple machines. So if we have a mechanical advantage of 4-to-1, it tells us that it is 4 times easier to do work, or the effort force magnitude is 4 times less than the magnitude of our resistance force. So it takes us, or we have to provide 4 times less force to lift some sort of resistance. But the trade-off is that in order to do that, we have to make it travel 4 times greater than the resistance force would be. So this shows an inclined plane. We'll talk about levers here in a minute. What is work in general? So it's making work easier for us. Work is force traveled in a distance, and mathematically work is equal to force times the distance traveled. Now that distance traveled, you can see on the picture here, the important thing is that the distance traveled is parallel. So I'm pushing with a force in this direction, and that means that my block is traveling then in the same direction, okay? There is also something where a force is going to be acting perpendicular, and when a force acts perpendicular to something, that is a different definition for us. We'll worry about that later, but perpendicular, remember, is a right angle. But we're not going to worry about that right now. We're talking about work, and work is when you have a force and it is applied parallel to the distance you are pushing whatever it is that you are making something move. So work is force times distance, and that distance again is parallel. Let me jump out of here quick. There we go. So there's the animation for you, exciting animation of Project Lead the Way's PowerPoints. Okay, so when we calculate work again, the product of the effort force times the distance traveled will be the same regardless of whatever your mechanical advantage is. But when we're talking mechanical advantage, that's the main thing we're going to focus on for simple machines, and 1 is the magic number. So what does that mean? If a mechanical advantage is greater than 1, that means you're making life easier for yourself when you're applying a force. So you require less effort force to overcome the resistance force, but you require greater distance to overcome that force. If your mechanical advantage is less than 1, you would use greater effort force, but you move something less of a distance. There's scenarios where you would want both, and so mechanical advantage can make that happen for us. You never can have a mechanical advantage less than or equal to 0. So there's 2 types of mechanical advantages, and the reason we worry about 2 of these, well, we'll get to that in just a little bit, but the 2 main types, they're ideal mechanical advantage. So what would you expect to happen? It's a theory-based calculation. You don't worry about friction, and you're just saying, what would I expect to happen based on the conditions that I have present in my simple machine. So you strictly are looking at distance traveled by both the effort and resistance force. And within simple machines, that distance is different in the setup of each simple machine. So each simple machine has a slightly different way of looking at it, but each simple machine also all uses the same ideal mechanical advantage. It's the same equation for all of them. So the equation for ideal mechanical advantage is the distance that your effort force moves divided by the distance your resistance force will move, or is from the fulcrum, or is from wherever you're looking at. But it's all about the distances when you are talking about ideal mechanical advantage. So IMA is ideal mechanical advantage. AMA is the other type of mechanical advantage we worry about, and that's when we are looking at what is actually happening. You worry about frictional losses, you are actually measuring forces, and you're using forces to figure out what is actually happening. So you have actual mechanical advantage. In this case, it's flipped, so that AMA is actually equal to FR divided by FE. So you can see that it's slightly different. Whereas before it was DE over DR, now it's FR over FE. And we'll show what that looks like, why that is mathematically here in just a second. But within this, you would never, in solving our problems, we assume that they're going to be equal. We'll talk about that in a second. But in real life, you will never really expect them to be exactly the same. Your actual mechanical advantage will always generally be slightly less than your ideal mechanical advantage, and that's how you worry about efficiency. So efficiency is when you have your AMA, you're comparing your AMA to your IMA, and you're figuring out how efficient your machines are. We'll talk about a little bit more on how we use these later, but that's the basis of mechanical advantage, and we'll stop it right there.